Now we're going to look at a function with a constant rate of change. So we're looking at f of x equals 2x minus 4. We're going to find the average rate of change of f between the following points. So our first two are x equals 3 and 6. So a is 3, b is 6, and we're still using f of b minus f of a all over b minus a. So we need f of 6 minus f of 3 all over 6 minus 3. So if we plug in 6, 2 times 6 is 12, minus 4 is 8. Plug in 3, 2 times 3 is 6, minus 4 is 2. All over 3. So that goes to 6 over 3, which is 2. Okay, for part B, A is A, B is A plus H. So we need f of A plus H minus f of A all over A plus H minus A. So we go to 2 times A plus H minus 4 minus parentheses A 2A minus 4. And we can simplify the denominator down to H. So the numerator becomes 2A plus 2H minus 4 minus 2A plus 4 all over H. So let's cancel our like terms. 2A, negative 2A, negative 4, and 4. We get 2H over H goes to 2. Wait a second, we just got 2 on the last one. So this is a constant rate of change because it is a linear equation. So our constant rate of change on a linear equation is actually our slope. Okay, increasing and decreasing functions. Functions are increasing when the graph rises from left to right and decreasing when it's falling. So if we have our coordinate plane, okay, where we have certain points where it turns. So our first point is point A, and then we look along the graph until we see it starts to turn, and the peak is right here at point B. So from A to B, it's increase. So we're going along the graph on B. Ignore my shaky hand on that graph. So we're going along B, and we see about right here. We're going to label that point C. It turns once more. So from B to C, it's decrease. And from C to D, the end. It is also increased. So technically, f is increasing on an interval I if f of x x1 is less than f of x2 whenever x1 is less than x2. So here's x1. It's coordinating y values f of x1 and f of x2. We can see that it's increasing on this given interval, and x1 and x2 create the interval. F is decreasing on an interval I, where x1 is f of x1 is greater than f of x2, when x1 is less than x2. So that means x1 and x2 are still in order from left to right. So here would be f of x1, and over here would be its f of x2, and we can see visually that f of x1 is higher on the y, so therefore it is greater than f of x2, so therefore it is decreasing. So we have the given graph where we have point -4, 2, 0, -2, 2, 3, and 4, -7. We're going to list the intervals on which it increases and decreases. Okay, so we see that the graph is going, if we read it from left to right, it's going up until -4, 2. What we care about is the x values, the domain. This is how we list the increase or decrease. So it's continuously going down if we go left. So if it was coming up, going left to right, it would start from -infinity to -4. -4 is included, so bracket. So we're looking for another increases. So we see it's going down, and then at 0, -2, it starts going up until 2, 3. So for the x values from 0 to 2, it's also increasing. Then finally at the end of the graph, it starts once again at 7 to infinity. For decreases, it's just going to be the x values that we haven't mentioned yet. So it decreases from -4 to 0, and right here from 2 to 7. Okay, for our last example, we're going to graph f of x equals x squared minus 2. We're going to state the domain and range of the function and the intervals in which it increases and decreases. So f of x equals x squared minus 2. We can go and find the vertex. So x equals -b/2a. A is 1, b is 0, c is -2. Because there's no b, it's 0, so x is 0. Then we got to find our y. So we plug in 0 for x. So y is -2. So our vertex is a point 0, -2. And then we're going to use the 1a, 3a, 5a if needed trick. So we're going to go up 1a over 1. A is 1, so it's going to go up 1 over 1 to both directions. From those, it's going to go up 3 over 1. 1, 2, 3 over 1. If you need help graphing parabolas, please let me know. And 5. So we see it is a parabola. So our domain, which is our x values, it will keep going to the left and it will keep going to the right. So it's all real numbers. Our range, we have a lowest point, we have a minimum on the parabola at -2. It will never go lower than that. So it's included and it will go to infinity. Now we'll state the increase and decrease. As we go left to right on the parabola, we are decreasing from the left until we hit 0, -2. And remember, we want the x values. So it is decreasing from -infinity to 0. So then it starts on an upward swing from 0, and we'll keep going to infinity.